Hello everyone. In this video we will learn how to convert a context-free grammar into its Chomsky Normal Form or CNF. We will work out a complex example that involves all of the steps and requires handling every possible cases that can emerge in this kind of problems. First, let's have a look on what is Chomsky Normal Form or CNF. So in CNF, each production rule of the grammar can only be of two kinds. First is capital A to capital BC, where A, B, C are each variables, and next is capital A to small a, where capital A is a variable and small a is a terminal. It also follows two more rules. First one is there cannot be any useless variables, and another one is there cannot be any null production from any variable. Only the starting variable can have a null production. We will see all these cases while we work out the example. So let's move on to the example. Here is the problem we are trying to solve. So let's do it step by step. First step is to eliminate useless variables. What are useless variables? They are of two kinds. First is we cannot reach the variable from the start variable by any kind of production, and the next one is that variable cannot produce any terminals. So here you can see that two variables are useless. First is x. This variable cannot produce any terminal, and next is y. You cannot get y from the starting variable a. There is no scope to get y. So we will eliminate these variables and write the rules without them. Our first step is done. Moving to the second step, we have to handle our start variable correctly. So in Chomsky normal form, the start variable cannot appear in any of in the on the right hand side of any of the productions. We can see that a is appearing on the right side of production rule 1. So we have to rewrite it. We have to create a new variable s that will give a, and next we write the previous rules same as they were. This was our second step. Third and fourth step is the critical steps of this conversion. Please watch it very carefully. In the third step, we have to remove every null productions. What are the null productions? Here are there are two null productions here. First is A gives epsilon and B gives epsilon. Which one we will remove first? We will follow a technique to remove the simpler null production first. Here you can see that B gives a null production, but B is used in A. I mean A produces B. So if we follow this technique, we will have a greater convenience to solve this problem. We will remove B first. So remove B to epsilon. While removing null production, we will have to write the we will write every rule at every step so that we don't miss any of the production rules. So if when we are removing null production, we will find where these variables are in each of the production rules. Suppose here a gives b a b. We will consider first case if b didn't give null production, and second case b gave the null production. So let's consider b didn't give null production, so we will write it fully bab. Now let's consider the first b gave null production, then we will vanish the first b, ab. Let's consider the second b gave null production on this BAB. So we will write BA. Now let's consider the case where both B produces null in this BAB. Then we will write only A. Okay, and there was a B remaining. We write it here. If B vanishes, I mean if B gives null production, then it will ultimately produce null. But our aim is to not write null or not produce null from okay, this is production rule A, so we can write null here for now. If B produces null, this will be actually the same as it, so we won't write it twice here. Okay, now consider removing the null production. So we have removed the null production from B and we have written it here. Now there is one thing special here, that there a production is being created A to A. This is nothing, this production means nothing, so we will cut it from here. When we write the final form, we won't have this A here. Okay, so there are another null production remaining. We will have to remove it. Remove A gives epsilon. Okay, so S to A, we write it as it is. Now we will remove this epsilon from here. So where does A appear? A appears from S. So we consider A did not vanish and we again consider A vanish. So if vanishes, it can produce a null terminal, null variable. So in the first one of the inherent rules, we said that except possibly the start variable, it can have only the start variable can have an epsilon production. So S can have an epsilon productions and we cannot omit it, but we do have to omit it from here. Okay, it cannot be present on any other variable except the start variable. Okay, so A gives BAB. We will follow the vanishing method here also. First let's do for this A gives BAB, we consider it fully first, then we will vanish A BB. This portion is done. Now this portion we will consider is not vanished and we will consider A vanished. Then this portion we will consider is not vanished and then we will consider it vanished. Okay, now A wasn't there because we cut it down at that time. There is another rule, another B, we will omit it and we cannot write epsilon here. So these are inherent rules. There are same productions again and again, so we will cut them. B, B, they are cut. Okay, so there was another rule, we will write as it was. So what the final production does is S A to epsilon, A gives B A B, B B A B, B A and B. Also B gives 0 0. Now we will move to the fourth step. The fourth step is to remove unit production. What are unit production? Unit productions are those that the variable on the left side gives a single variable on the right side. So we can see that there is one unit production here. A gives B. One variable gives one variable. This cannot be present in Chomsky normal form. So we will remove the unit production, but in each step, as I said, I will write all of the rules. A gives B A B, B B A B, B A, and we will replace the production here 0 0, but we will not remove the rule itself. Okay, we replace the unit production by what the unit variable produces, but we will not remove the rule itself. So there was another unit productions that I was about to tell, that is S to A. S to A cannot also done here. So uh, that was first, and in the second step we will remove S gives A. You can see here I am also using the technique that I told in the third step, is that remove the variable that doesn't have any dependencies, or the simpler variable first. If we remove first time, then we will have a lot of complexities in the reduction. Okay, if we remove B first, I mean the production A to B first, then our life will be easier. So let's now remove S to gives A. S gives A, we will replace in A whatever was there. That's the point. So S gives B A B, B B, A B, B A, or 0 0. B gives A gives B A B, B B, A B, B A, 0 0. A very important thing here that people do mistake very often is that they forget to put the epsilon here. So that was also a production rule, S to epsilon we cannot omit, because the start variable can have epsilon productions. What we did is we just replaced this whole production here and nothing else. We didn't remove the A. Okay, so there was another rule remaining, B00. Our fourth step is also done. From fifth step it is simpler. In these steps we have to remember what the Chomsky normal form actually was. It can be only from these two rules, A to BC and A to smaller a. So we can see that there are two terminals here, but the Chomsky normal form cannot have two terminals. It only should have one variable to two variable, and one variable to gives one terminal. Okay, so any other combinations are not allowed in Chomsky normal form. So we will have to rectify those wrong productions so that they are corrected and converted to Chomsky normal form. So to remove these two terminal combination which is not allowed, we will convert these variables into a representation, these terminals into representations of variables. We will introduce a new rule, C to 0. So S gives B A B, B B, A B, B A, C C, or epsilon. Also A gives B A B, B B, A B, B A, C C. B gives 0 0, and our new rule we will write it here, C gives 0. Okay, now in the sixth step there are also another controversy here, that is three variable combination. It is not allowed here. We can only allow two variables. Our rule is very simple, we will break the three variables into two variable and one variable. So let us consider D let us consider D gives AB. Okay, so we will write this D representation here. F gives BD, BB, AB, BA, CC, epsilon. A gives AB, BAB, we will write BD, BB, AB, BACC, and C gives 0 0, sorry, B gives 0 0, C gives 0, and we will have to write our new rule here. So let me reduce the text size, and our new rule will be written as D gives AB. So that was our final Chomsky normal form. You can easily see that it follows all the rules that I stated here, and that was an example involving all the rules and all possible cases. If you practice more and more, you can get a good grip on this kind of edge cases, and also produce your rules, your personal rules, like removing the simpler productions first, so that any dependencies are not created, and so on. So that was it. If you learn something from good from the video and like the video, please do share it and like and subscribe. Okay, thank you.